Hello, this is Vignesh here, welcoming you all to my channel Educators Inc. In the last two videos, we had seen about the first law of motion and what is inertia and some examples of inertia. In this video, we shall learn about the second law of motion. Now, the first law of motion states that if an unbalanced force is applied to an object, its velocity changes, that is, the objects get accelerated. Now, we shall understand how the acceleration of an object is dependent on the force applied and how do we measure this force. Now, we'll see some day-to-day examples during a game of table tennis. If a ball hits the player, it does not hurt him. But similarly, if a ball in a cricket match, if a ball hits a spectator, it might hurt him. Similarly, if a truck is at rest and is parked along the roadside, we do not need to be aware of it. But if the same truck is moving with a velocity of 5 meters per second, it may kill a person. Similarly, if a bullet released from a gun may hit or kill a person. Now, this example suggests that the impact of an object depends on mass of the object and velocity now how there must be some term that relates these two quantities. Now the term that relates these two quantities is known as momentum of the object. Momentum of the object is defined as the product of mass of the object in the velocity of the object, that is P is equal to mv. Now momentum has both direction and magnitude. The direction of the momentum is in the direction of the force. Now suppose the SI unit of momentum is kg meter per second. Now, since the applied force brings change in the velocity of the object, it also brings the change in momentum. Now, consider an example. If we have a car with dead battery moving on a straight road, now we need to push to start the engine of the car. We need to push the car with a acceleration of 1 meter per second. Suppose two persons are moving a car for a certain distance, it may not start, but if it is moving for a certain time, it may gain an acceleration and the engine may start. So this example suggests that the change in momentum does not depend on magnitude, or does not only depend on the magnitude of the force, but also the time taken or time during which the force is exerted. Therefore, we can conclude that the force necessary to change the momentum of an object depends on the time rate at which momentum of the object is changed. Now, the second law of Newton states that the rate of change of momentum is directly proportional to the applied force in the direction of the force. So, this is the second law of motion. Hence, we conclude this video. In the next video, we shall derive how to measure force, that is F. F is equal to ma. Please like, share my video and subscribe to my channel by clicking on bell icon. Thank you.